In the last video we created a CRUD API with the FastAPI framework, but we used in-memory data. In this video we're going to convert that and we're going to use a relational database along with the SQLModel library. This is a new library for interacting with databases and it's built by the same author as FastAPI. So in this video we're going to use that and we're going to use a relational database. Now let's start by looking at GitHub. We have here a repository and this contains starter code and also in the video 1 branch the code from the previous video. What we're going to do in this video is convert this code that we have from the last video to use a relational database. Now the SQLModel library is here and it makes interacting with SQL databases easier when you're using frameworks like FastAPI. SQLModel is built on Python type annotations and it's powered by Pydantic as well as SQLAlchemy. So we're going to see how to use that in this video. Now the first step in this video is we're going to actually set up a database. So I'm going to create a new file within this project and it's going to be called database.py. And this file is going to contain the setup code for our database. And I actually wrote a blog post on this quite a while ago. So we're going to follow the steps throughout this post here. The first step, of course, is to install the SQLModel library. So let's go to the terminal and we can run the pip install SQLModel command. And once that's installed, we can go back to the documentation for SQLModel. And on the right hand side, there's an example and we're going to follow that to set up the framework. And we're going to set up a SQLite database. So let's scroll down here and we have a few imports. So I'm going to copy these into our application, into the database.py file. As well as optional, we're importing a couple of things from SQLModel, field and the SQLModel base class. This is what we're going to extend when we create a class that represents a database table under the hood. And if we go back to the documentation, you see that it creates a class here and it's called hero. What we're going to create is a track class that represents a music track. This is in line with what we did in the previous tutorial. As you can see here, we have a Pydantic model representing a track. And what we're going to create now with SQLModel using this base class is something that's very similar and it's going to represent the structure of the underlying database table. So let's create a class and we're going to call it track model. And this is going to inherit from that SQLModel class above. And like the documentation, we also specify table equals true, which will tell SQLModel that we want this to be a database table. Now within the class, we define fields that represent the columns in our database table. Going back to the documentation, you see there's columns here for ID, name, and so on. And these each have a type associated with them. For example, a string data type will map to a varchar column in the underlying database, and that's what these type annotations are designed to do. They tell SQLAlchemy what the data type should be in the underlying database, but they also provide validation because this SQLModel class actually inherits from the Pydantic base model. So as well as database structure, we also get validation built into these classes. So let's now define these columns within our class. We're going to copy this ID column to the table because our data does have an ID. And you see that this is an instance of the field class that we've imported from SQLModel. It's an optional integer data type and it has a primary key equals true parameter. And that tells the table under the hood that this is the identifier for each row. Now what we're also going to do is basically copy these from the Pydantic model that we defined in the last video and we're going to paste them into the class like that. And we also need to import the datetime object at the top here. So this is our SQLModel class and it represents the data that we're modeling. And what we now need to do is actually create the database and create the table under the hood. So what we're going to do is go back to this blog post that I wrote, and here we have a function called create tables, and I'm going to copy this into our file just down here below that class. And this line within the function, it says SQLModel and there's a metadata field on that with a create all function, and to that we pass an engine that will interact with our underlying database, which might be SQLite or MySQL or Postgres or any other database. What we now need to do is create that engine. Now we're going to work with SQLite, which is a very simple database. It's just a file. So let's go back to the blog post and we can see a couple of attributes at the top here. We've got a database file and an engine definition. So let's paste these into the file. And finally, we need to import the create engine function from SQLModel. So we have a database file. It's called db.sqlite3. And then we define an engine on line 7. We call the create engine function and we pass a reference to this file that we're going to create that represents our database. So now we have an engine definition that we've created with this create engine function. The final thing we're going to do in this file now is create a main function, and within that we're going to call this create tables function, which is going to create the database and the table. So let's go back to the blog post, and we're going to copy this bottom part here, and we'll paste that into our file at the very bottom. Now what this means is that when we call the database.py script using a command, then these lines are going to be fired, and it's going to call this function which creates our table using this SQLModel metadata create all function. And there's more information about this function here. I'll leave this link in the description. So let's try calling this file now. It's going to be python database.py, and we should see some statements have been executed. You can see a create table SQL statement being executed here, and that creates all of these columns, and it also specifies the primary key. So that should have created our database, and you can see on the left hand toolbar we've got a db.sqlite3 file. And we can inspect this database using the SQLite Explorer, and you see that there's a track model table with those columns. So that seems to have worked. Let's now convert our application, which is in main.py, to use SQLModel and a relational database. Now remember, the first step was to load this JSON data into the application. What we did in the last video is we used a startup event, and we loaded it into memory into this data variable here on line 13, which is a simple Python list. We're now going to demonstrate some SQLModel here, and in this startup event we're going to change the way that data from the JSON file is loaded, and we're going to load it into a database instead of an in-memory variable. Now in order to do that, we're going to need to import some of the things that we've just created in the database file. Firstly, we're going to import this track model class that we've created that represents the database table, and we're also going to import this engine here. Remember, we need the engine to actually interact and query the database, so we need to import that. So let's go back to main.py, and at the bottom we're going to import from the database module the track model and the engine, and above that we're going to do a couple of imports from SQLModel. We're going to import the session object as well as the select statement, and we're going to use these to query and insert data into the database. We're going to see how to do that now in the startup event. Now let's clear out all the code below this data file. We're going to point still to the same data file, which is tracks.json. You can get that on the repository, but now instead of loading it into memory, we're going to load it into the database. Now the first thing I'm going to do is create a session object, and we're going to pass the engine to that, and that will create a database session that allows us to query and interact with the database. Once we have that, we're going to check if the database already contains the tracks. That's so we don't create duplicates when we start the server. So in order to do that, we set up a database statement, and we're going to select all of the track model instances, basically all of the tracks in that table. And when you want to select all rows of a particular type, you can create this select command here, and you pass to the model that you want to get the data for. So that's the statement. To actually execute the command and get a result, we're going to use this line here. It's the session object, which has an exec function. We pass the statement to that function, and that will give us back the objects from the database. And to get the first row from the database, we can call the .first function. That's very similar to what you can do using the Django ORM. That will give you the first row in that result set. Now the purpose of that query is to check if there's any rows in the database. What we want to do, if there's no rows, and only if there's no rows, we're going to load the data from that JSON file. So we can say if the result is none, then we're going to load the data from the file using the same code from the previous video. We open the data file in read mode, we load the JSON data into a dictionary called tracks, and then we are going to iterate over those tracks and add them to the database. Now we're going to see how to insert data using SQLModel. So for each track in our JSON data, we're going to use the session object's add function, and to that we're going to pass a model. Now we have a JSON record for the given track that we're iterating over, so we're going to create a track model instance from that, and we're going to destructure the track that we're iterating over to create that, and that will pass the data in this dictionary as keyword arguments to the model. So in other words, for every track in our JSON, we're creating a track model instance, and we're adding that to the session here. And after that's completed, we're going to commit these changes to our database. So we call the session.commit command. And that's all we're doing in this function, but we do need to close the session as well. So we call the session.close function. And it's worth noting that later in this video, we're going to use a context manager to create the session, and that will allow us to do that without having to close it off at the end. So once this is done, what we're going to do is start up our our 𝗬𝗵𝗽𝗶𝗹 server, and when we start the server it's going to invoke this startup event, and that should hopefully load the data into the database. Let's check the SQL Explorer here. We're going to show the table, and you can see we now have data in our database. So that seems to have worked. What we're now going to do is we're going to modify our CRUD API. Rather than working with the list of data, we're now going to query the database to make these changes, to get data, to update data, to create data, and to delete data. So let's start with this simple endpoint here. This is the one that gets all of the records from the data. So for this endpoint, we simply want to select all from our table. So let's see how to do that now. So in order to query all records from the database, we're going to use a context manager to create the session. We pass the engine to that session as we did before, and now we don't need to manually close the session at the end of the function. We then create a statement, and we're going to create a select statement, and we're going to select all of the track model instances. We can then get a result using the session.exec function, and to that we pass the statement above, and then we can call .all to get all of the rows from that database. And rather than returning data, we're going to return within the context manager, we're going to return the result. And all of the parameters to the app.get decorator can stay the same. We're still returning a list of tracks. This time it's going to be results from the database that we grab using this query here. So let's go back to the API here, and we're going to test this out and see if it still works. You can see that we are still loading all these JSON records, and it has the data that we expect. So that's the first function done to get all of the tracks. What we're now going to do is modify this function here, which selects a track by its ID. So let's start by clearing these lines here, and again we're going to create a session object. So I'm going to copy this code here to create a session. We're going to copy that down here, and in a minute we're going to refactor this and create a dependency that will inject the session, so we don't need to keep writing that in every function. For now we're just going to create another context manager, and we're going to find this track by its ID. Now if we jump back to the SQLModel documentation, you can see that we have a shortcut to get an object by its primary key, because as it says, that's a very common operation. And there's a session.get function. To that you pass a model instance as well as the primary key itself that you're searching for. So we're going to use the session.get function in our code here. Remember, the track ID is passed in the URL as a dynamic parameter. So what we're going to say is the track is equal to session.get. We pass the track model, that's the SQLModel class, as well as the track ID itself, and that will search for that track ID in the database. And we're then going to check if the track is none, so we'll tab that code from the previous video over. If it is none, we'll return a 404 not found. Otherwise, we're going to return the track itself. Nothing else here needs to change. Let's test that out on our API. Now here's the data, as you can see, for all of the tracks. If we add the ID of 1 to the URL, and if we execute that, we see we get back only the track with the ID of 1. So that's working fine. Let's see now if it works for an ID that doesn't exist, such as 9999. And you see we get back track not found. So that's all working fine. We now have an endpoint that allows us to get tracks individually by the ID, and it uses the session.get function from SQLModel. Now we're going to move on to the post request in a minute, but before we do that, you should notice this repetition here within two different endpoints of the session. We're creating a context manager in two of these endpoints, and we're going to have to do that in all of them because every one of these endpoints will interact with the database, therefore it needs a session. Now we don't really want to write this code in every function, so what we're going to do is create a FastAPI dependency, and we can look at the documentation for FastAPI to see what that is. It allows you to perform dependency injection in your FastAPI functions. Now I'll link this page below the video. On the right hand side there's a section for creating a dependency. Now the key point is a dependency is just a normal Python function, and this function either returns or yields a particular object that you can then inject into your FastAPI functions themselves using parameters here, and you can see this depends construct from FastAPI, and that's exactly what we're going to do now. And we're going to follow the guidelines from this page on the SQLModel documentation, and I'll link this one below the video as well. And what we're going to do is create a dependency that yields the session, and then we can inject that into our functions. In order to do this, we simply have to copy this code here and we need to paste it into our file. So I'm going to do that at the top. Just below the startup event, we paste that function, and this function is called getSession, and we can then use that in our FastAPI functions by injecting them as parameters. If we go back to the documentation, you can see that how we use this is that we specify a session parameter of type session, and then we set that equal to a dependency using this depends construct from FastAPI, and we pass a reference to our function to that depends construct. So let's copy this code here, and we're going to inject that into the two functions that we've already created. Firstly, the track function, and also we're going to copy it into this function here that gets a track by its ID. And we also need to import depends from FastAPI, so we can do that at the top. And once we've done that, we can actually remove the context managers from these functions. So let's do that and tab over. And the same with the function below here. We don't need these anymore because we're using dependency injection. So let's quickly check that these are still working by going to our API, and we can see we get back the detail page, and that also works for all tracks as well. We're getting all of these objects back. So now we don't need to create a context manager in every function. Now all of our FastAPI endpoints are going to use this session, so to the post endpoint we're also going to inject it into the function. Now this post function takes the track as JSON data from the client, and it's going to create a track object in our database from that data. Now we're going to replace all of this code, including this line here that assigns to the ID, because we specified in the database model that it's a primary key. We don't need to manually take care of creating that ID anymore. Instead, the database is smart enough to do that using auto-incrementing schemes. So let's just remove all of this code, and what I'm going to do is we're going to change the track that's being injected here from a Pydantic model to a SQL model. So now instead of just the Pydantic class, we're actually using this class here, which, remember, it's a subclass of Pydantic's base model. So we can also do our validation with this class as well as using it to interact with the database. So let's go back to main.py, and what we're going to do within the body of this function is we're going to add the track data we get from the client to the session. Remember, we're type hinting it now as a track model, and we can now add it directly to the session because we're type hinting it as a SQL model subclass. Once we've added it to the session, we can then commit it to the database, and that will actually create the row within the database table. And once we've committed, we're going to refresh that track from the database. Now what that means is, as you can see here, the ID is optional. When a client creates a new track, it sends JSON data, but we don't want the client defining an ID. We want the database to create that ID. So when the client sends the data, this will not be sent in the JSON data. What we need to do within main.py, when we commit the track to the database, it's going to create an ID for us. But to actually get that ID back to a Python application, we need to call the session.refresh function and pass the track instance to that. Now this is well documented in the SQLModel documentation. I'll leave a link to this below the video. In their example, they add a hero to the database and then they refresh that after committing. And finally, we're going to return that new track to the client, and that will give back the data that we've created in the database. So let's test that out using a curl command. Let's go to git bash, and I'm going to execute this statement here. It's a curl command that sends a post request, and we're creating a new track in the database with this data here. It's by the band Sonic Youth, and it has some other fields as well. We're now going to go and see if that has been created within our API. If we refresh this page, since it's a new track, we're expecting to see it maybe at the bottom of this data, and you can see down below here that it exists here. So we're successfully creating new data in our database using SQLModel, and you can see that we do that by adding an instance of the class to our session and then committing that to the database. And as I said before, when we actually send a post request, as you can see here, we don't specify an ID. We let the database define that ID, and that is returned when the database object is actually created. And that's because we use this session.refresh to get that ID from the database after the object has been created. So I hope that makes sense. Let's now move on to the put endpoint. Now the put endpoint allows us to change data that already exists in our database. Let's see how we can do that using SQLModel, and let's start by removing this track from the function here. And we're going to copy the code that gets a track by its ID from this function here. Remember the session.get function, and we're going to paste that in here. And you can see that we don't know what the session object is, and that's because we need to inject it into the function as we did with all of the other functions. So we can do that here. And to clean this up, you might want to put each parameter on a new line, but we're going to leave it like that. And what we're going to do is, if the track is none, we simply return a 404 not found. Otherwise, we're going to modify this code here, the for loop, to update that to work with SQLModel and our database. So what we're going to do is we're going to take the updated track data, and this is the data that's been sent to the server that we're going to update the record with. We're going to take that and we're going to convert it to a dictionary. So let's call that track dictionary, and we're going to set that equal to the updated track converted to a Python dictionary, and we're going to use an argument called exclude unset, and that is going to be set to true. And what that means is, because we're sending data to the server, we don't want to be sending IDs, we don't want to change the ID of a record, so that will exclude that ID from the dictionary that's created from the Pydantic model. And there's a good explanation of this in the SQLModel documentation. It's under this section here for getting new data. Basically, if you call the .dict function on a Pydantic model, if there's a value that's not set, it will set that value equal to none. And that's the case for our ID. We don't want that ID to be none. So Pydantic models have this parameter _unset, which you can set to true. And if you use that, any values that are not set in the Pydantic model will not be converted into the dictionary. So that's the purpose of the _unset parameter. Let's now update the database record in our code. We're going to update this for loop, and we're going to reference the track dictionary.items here. So for each key and value in the dictionary that we get back from line 81, what we're going to do is we're going to call the set attribute function. That's a built-in in Python, and the first parameter to that's going to be the track that we got on line 73 above. That's a SQLModel instance, and on that class we're going to set the key equal to the value that we're getting from the updated tracks dictionary. So for the updated track sent to the server, we convert that to a dictionary that does not contain the ID or any other unset parameters, and then we loop over that dictionary's items and we update the values on the track that we pulled out of the database here on line 73 with the new value. And once we've done that, we're again going to use the session, and we're going to add the track to the session, and then we're going to commit that change to the database. And finally, we're going to refresh that from the database, and that will return the up-to-date data. So now that we've done that, let's test this in the command line. We're going to execute a put statement, and we're going to change the track with the ID of 2 to that Sonic Youth track. If we execute this, we should then get the data back, and we can then see whether or not that's been changed by going to our API, and we'll refresh. If we look at the track with the ID of 2, which is this URL here, and we execute that, we now see that that data has been updated. So the put request has worked. We're updating the fields based on the data that was sent to the server in this put request using the -d parameter, as you can see here. So that's the put request. We're now going to finish the video up by using a delete request in order to remove data from the database. So let's scroll down to the delete function here, and what we're going to do again is inject this session into this function using the dependency, and we can remove this code here on line 94. Again, we're going to fetch the track from the database, so we're going to get the track by the ID that's in the URL, as you can see here. So we're getting a track model instance, and we're getting it by the track ID in the URL. Again, we're going to check if that track is none and return a 404 not found if so. Otherwise, we're going to remove these lines here, and we're going to delete this item from the database. So we use the session.delete function that exists on the session object, and we pass the instance to that, the track instance that we got from the database on line 93. And once we've deleted that, we need to commit the change to the database, and that'll actually make that change happen. Once we've done that, that's basically all we need to do for our function. We can now test it out on the command line. Let's try removing the track with the ID of 1. To do that, we specify a delete request using the -x delete, and in the URL we have track ID 1 here. Let's execute this and we'll see what happens. We don't get a response back on the terminal, but if we go back to the application and the 𝗰𝗿 server here, we've got a 200 OK for that delete request. That means it's hopefully worked fine, and we can go back to the browser and we can go to the API. If I replace the ID with 1 here and we execute that, we get track not found. So that has been deleted from the database. So that's all for this video. We're using SQLModel and relational databases to create this CRUD API with FastAPI. And we have endpoints for creating data, for updating data and deleting data, as well as endpoints for retrieving all data and retrieving items by their ID. And we're using SQLModel here. We're using the session that we're injecting as a dependency. And this is a very basic example of an API for track data. And if anyone's interested in more videos with these tools, we can delve into authentication with JWTs. We can delve into things like searching through records by query parameters. So if you're interested in any of that, leave a comment below. And if you enjoyed this video, please like and subscribe to the channel, and we'll see you in the next video.